The DEMETER Pilot 1.3 provides a smart irrigation service in rice and maize cultivation. Its goals are to maximize water use efficiency in the rice-maize crop rotation system through appropriate sensors and science-based decision making, and at the same time optimize the spatial distribution of nitrogen application, since irrigation is tightly linked to fertilization in this crop system. To do so, it provides three services. The first one, rice irrigation, is based on custom sensors called YZ nodes, which measure salinity and water height in real time throughout the growing season. Here you can see some photographs from the sensor installation. At the same time, we deploy automated input and output electrical valves in order to control irrigation. These valves are equipped with GSM modems and can be fully controlled through specific SMS messages. On the left side, you can see some videos from the valve's operation throughout the growing season. On the top right, you can see how the valve can be controlled through specific SMS messages, whereas on the bottom right, you can see such a system deployed on the field a week or so ago, just before harvesting. The objective is to start water flow when salinity increases past the critical threshold until it drops below. That way, we reduce the risk for salt toxicity in the rice plants. Generally, we monitor water height and maintain it within predefined limits to also increase water use efficiency. The second service, maize irrigation, provides decision support for irrigation in maize crops based on thermal and multispectral UAV imageries, plus weather data and predictions. Now, advanced machine learning model approaches are used to forecast weather conditions, and an empirical system is being built that fuses all this data and provides irrigation advisory service for maize crops through commercial, very high resolution multispectral satellite imagery at the end. The third service, the fertilization one, is based on nitrogen uptake estimation from UAV imagery. A model is built in small-scale plots calculating different spectral indices. Machine learning algorithms are employed to select a minimum set of required features and then to model the nitrogen uptake estimation, out of which the nitrogen application recommendations are derived. For a large-scale application, the trained model is applied to very high-resolution commercial imagery, but for larger parcels, Sentinel-2 imagery can be used instead, with satisfactory performance. In both cases, we can produce map for the whole region and then select the specific farmer's plots, which reduces our costs. Finally, the maps are provided to farmers for use with variable rate technology spreaders. Several enablers have been developed and deployed for Pilot 1.3 in the DEMETER platform, including pilot-specific ones. All these operate in the background and are fully integrated with the DEMETER ecosystem. The pilot has been deployed in Central Macedonia in Greece, near Thessaloniki. During the pilot round 1, we involved 2 farms with a total area of around 60 hectares. During the pilot round 2, in the 2022 growing season, we increased that to 5 groups of farmers with a total area of 150 hectares. But additional demonstration of farming schools are planned for the beginning of the 2023 growing season during the DEMETER extension period. We did perform targeted dissemination actions involving mostly agricultural cooperatives in the region, as well as key farmers and agribusinesses in the area. We also disseminated through targeted workshops where ELGO usually frequently participates in. In terms of performance now, the pilot defines 3 pilot-specific key performance indicators: decrease in irrigation water consumption, water salinity in rice crops to remain below a critical threshold, which will result in salt toxicity, and of course reduce cost for fertilizer. Even during the first round of pilot applications in DEMETER, we achieved very encouraging results, meeting at least the minimum targets. Initial results during pilot round 2 indicate that we did much better, although We are still waiting for the yield measurements in order to be certain. Pilot 1.3 in DEMETER is being run by the Hellenic Agricultural DEMETER and the Institute of Communication and Computer Systems in Greece.